So self-inductance of a coil depends upon number of turns, area and its length. So this is the formula for self-inductance of a solenoid, self-inductance of a coil. Okay, so once again, if we want a very high EMF, what we can do? Use a coil, give it current and switch it off. When we switch off, how much time we take to switch off? Almost no time. It is a very, very small time, and we know that how much will be at the time of switch off. How much is the E induced? This is equal to L di by dt. This. And this dt is so small that this value is very high. So EMF is very high. When we switch, if we switch off our tube light, we have voltage at our home 200 volt, 220 volt. When we switch it off, there is an inductor there, and because of this, there is induced voltage of 400, 500, 1000 volt. So high voltage. And because of that high voltage, the current start flowing in such a long tube light. And this work, make and break of the circuit is done by starter. You have seen starter in the tube light. When we switch it on, that starter make, break, make, break, make, break. When it breaks, the voltage becomes very high between the two electrodes. That voltage is so high that the gas in the tube gets ionized and the current starts. And when the current starts, then that is the path of the current which is flowing through it, then it does not flow through the starter. So starter function is over. After that we can remove the starter. The tube light will flow the current. Initially there was no current in the tube light, so the current was going through starter. And starter was in the action. Make, break, make, break. Whenever there is a break, very high voltage. High voltage, the gas get ionized, current start, and then current will pass through it. Okay, so that is this. So this inductor we are using to produce very, very high EMF, very, very high voltage. So that is job of inductor. Now a very small thing, once again, when we switch it off, it is giving the supporting current, so that current takes a little time to reduce to zero. By that time it supports. Why it support? From where it gets the energy, and why it support for only a very small time? There are two things. First, there should be a source of energy. So when we increase the current, at that time it stores the energy, because when we send the charges, it opposes due to magnetic field, and a lot of magnetic field is formed in it. That magnetic field stores the energy. How much is that energy? See, we know the formula for energy. Here I will write energy stored in inductor. Energy stored in an inductor. Power has a formula. Power is equal to E into I. This we have studied. Now, power itself is, for a very small time dt, this power has a formula dw by dt, and this is E has this formula L di by dt into I. dt is cancelled, and we have dw is equal to L di into I. Integrate both sides, so work done is equal to L I di has a integration I square upon 2. And this work done converts into potential. Potential energy stored in the inductance. U is equal to half Li square. This is the energy stored in the inductance. Now the question is, where is this energy stored? Answer, when the current flows, there is a magnetic field formed here. This energy is stored as energy of that magnetic field, that magnetic flux, which is present here. So we make a note here, energy stored in magnetic flux. So we call it UB, magnetic field energy. So this is the energy stored in the inductor, and this is the energy it is going to use when the current is dying down. The same energy it is using to promote the current, to continue the current, but it is a limited stock. The moment this energy finish, it cannot continue the current, and finally the current becomes zero. So for a moment, there is a EMF, very high EMF. The current starts increasing. That means the current remain there. It does not decrease, but that is for a very small moment. After that, energy finish, the current goes back to zero because we have disconnected it. So this is working of inductor. Please remember, this is the energy stored in magnetic field. This is the formula for energy. Remember, you see this formula? Mechanical energy, half mv square. M is a constant, v is variable. In capacitor, energy is half cv square. C, capacitance. Voltage, the quantity which is variable. In inductor, it is half Li square. L, constant. I, variable. So it has got the same type of sequence. In the spring, it is half kx square. K is spring constant. X is the displacement we are increasing. So this is a standard format of energy. In this, where is energy stored? In the magnetic field. In capacitor, it is stored in the electric field. In the spring, it is stored in the, mechanical energy of compression. Okay, so this is all about self-inductance.